Well, hey everybody. Today we are going to be capturing part of our Chapter 8 information and adding one new additional thing to it. So, you might remember that, that's massively large. There we go, much better. You might remember that, of course, Chapter 8 is about our introduction to polynomials. Okay, we learned a few things. We learned that the degree of a monomial, in order to get the degree of a monomial, which is one term, the degree of one single term, all we do is we add up all the exponents, however many variables they are, just add the exponent on every single variable. That'll give you its degree. We did learn that there's a thing called standard form. We put terms in order from the largest degree to the smallest degree. So you may have like 3 terms. Well, each term has its own degree. Whichever term is largest goes first. And then we had this nifty little sheet. Here we go again. This, kind of like what I did here, this is what we would call or consider like a cheat sheet. Key ideas that we want to make sure that we put onto like an index card or something, in case if we're allowed to use something like that for a test. Okay, see how I took this classification system and I broke it down into a tiny little thing. Basically, we have what? First names for classification, last names, and the first names go by the degree. So, and we also have a last name, which goes by the number of terms. Well, if you have a degree of 0, then it's called a constant. If you have a degree of 1, it's called linear. If there is only one term, it's monomial. If there is a degree of 2, it's quadratic. If there's only 2 terms, it's a binomial. If it's 3 terms, degree of 3, it's a cubic. And then if it has 3 terms, it's a trinomial. 4 or more, it's 4th, 5th, or 6th, 7th, 8th, 9th, 10th degree. For last name, it's a polynomial. So let's say we're given, for example, let's say we are just giving this. All right, and we have, I'm just pulling numbers out of my head. Let's do an x to the 3rd power plus 1. Notice that we have what? The degree of the first term is 3. The degree of the last term is 0. Okay, so for degree-wise, that's how we choose the first name. We would have to say, well, the largest degree is 3. So you come down here, 3 is cubic. So this is a cubic function, or cubic. And then to get the last name, we say, well, there's 2 terms. So we look, 2, go across, it's binomial. So it's a cubic. Binomial, I'm going to just abbreviate that there. And that's how you would use this little chart. This is why little tiny things like this are great ideas, super important to put in your notes. Just like a tiny little list of all of the exponent rules that we just learned. If you have that as a quick reference, it's great for tests or to put on note cards if you're allowed to do that for a test. Great study tip. Here's something that's new. What if the degree of what we're looking at is less than 0? Notice, we have what? We have a degree of, we're going to put these in order. If we're going to write this in standard form, we have a degree of x to the 2nd power. Then, look, that's a degree of 1. I'm sorry, 1 is a degree of 0. And then we have what? X squared plus 1 plus 3x to the negative 2 power. Is this a polynomial? I'll ask it. That's a great question to ask. Maybe you'll be asked this on a test or a homework sometime. Is this a polynomial? Is this a polynomial? What do we think? What about this one? The degree of it, there's only one piece. This is a monomial, but it has a degree of -2. A degree of -2. Is this are either of these a polynomials? Well, here's something we're going to learn new today, okay? It's not hard. Polynomials always have a degree of 0 or larger. So these are not polynomials because they have a degree in them that's negative. You cannot have a negative degree in a polynomial. Not so bad, right? A new edition. Got to do something new every day. That's what they say anyways. We learn something new every day. Now let's apply what we've done this last week, okay? So last week we finished up the week with multiplying. We were using the box method and stuff. So of course, how can we increase our depth of knowledge? How can we make our level of problem solving even stronger? We use real world applications. We put it into something like this, where it is now sitting here in a word problem. So it says an area rug measures 2x squared plus x plus 1 by x plus 4. So these are the length of an area, the area rug. Okay, it measures from here to here, the total outside. You have your dimension here. It has a light border, which we can see in our little picture, and it has a dark rectangular center that measures x plus 2 by x minus 3. They want to know what is the area of the border. So the border is the light part. Well, we have enough information here to calculate what is the area of the total rug, right? We could say that I would guess myself that this area here is like x plus 4. And then this side area here would be the long area. That's like the 2x squared plus x plus 1. That is ugly too. All right. Not a crazy looking x2. And then we see these measurements are the measurements for the inside. So, what do you think we have to do here? This is an interesting problem. So, I'm going to say the first thing we know we can calculate for sure is we can calculate what is the total area of this rug, right? So we have a 2 by 3. Let's go ahead and we'll make a... Oh, that box. This is why I drew the boxes on the previous notes. It isn't the best for making straight lines. So you have a 2x squared, an x, and a 1, and an x, and a 4. Let's get that total area. So 2 times 1 is 2. Hopefully after our homework from last Friday, we have got this down. Base stays the same. Add these exponents. Remember, there's a hidden 1. So 1 plus 2 is 3. X times x is an x squared. X times 1 is just x. Well, 4 times 2 is 8. X squared. 4 times x is a 4x. And 4 times 1 is 4. All right, we've already finished step 1 because we set it up. We already finished step 2 because we multiplied the boxes. Now we have to get, well, what's on the inside of this box. So let's start to add these. Remember, if we did our job right, these diagonally should all end up being the same and line up, and they do. So we are ready to grumble. So we end up here with what? 2x to the third power plus, well, we have what, 8 of these, and one of these gives us 9x squared. We have a 4x and a 1x, so we have 4 plus 1 is 5, so there are 5 total x's there. And then the lonely 4 comes on over. So this is the area of the total rug. The total rug's area is 2x to the third power plus 9x squared plus 5x plus 4. Great. Now what do we do? Well, they did give us some more measurements here, right? They gave us the measurements of the dark rectangular center. So if we know the whole area of this rug, and we can subtract the area of the dark center here, it should give us what's left is going to be the area of that light center. So now we have to do this again. Well, one side was what, x plus 2. And then we had an x minus 3. This becomes an x squared. We have a 2x minus 3 x. And again, these are power rules, guys, so you need to make sure you're good at this. And 2 times negative 3 is a negative 6. Perfect. So we have filled in our box. It's time to leave. Now, if you remember from the beginning of this section, we said this is making us do everything together. We are adding. We're doing power rules. Then we're adding and combining like terms to get out of the boxes. Twice multiplying the binomials, and then we are also having to subtract binomials. So again, remember when we do this is a subtraction problem, so we have to have parentheses. We have to set this up right so that we remember to distribute that pesky little negative 1. Let's get out of this box. X squared comes out. We have a negative 3x and a positive 2x, so we have a negative x. Remember, like if you owe somebody $3 and you pay them back 2, you still owe them $1, and a minus 6. Now we have to be very, very careful here. We need to do what? This is the one where I told you when we get to a problem that looks like this, there should be a couple steps. We should distribute this, should be distributed first to each piece. So this becomes a negative x squared, a positive x, and a positive 6. That was our step 1. Take this, rewrite it. 2x to the third plus 9x squared plus 5x plus 4. Now we can combine our final terms. So we have a 2x to the third power, and then we have what? Plus 8x and like that, you've solved every single piece down the line very carefully. And notice, if you take a look at this one, is this one smaller or different from this? Yeah, if this is the total area, this should definitely be smaller. And it is. So chances are we've got this pretty good. It looks like it's quite right. And you should be all set and ready to go. All right, today you're going to notice we have a mixed review. Yes, I'm bringing back a couple of problems from making sure we know how to do exponents. There's going to be a new problem that deals with being able to identify, well, is it a function? Or I'm sorry, is it a polynomial or is it not a polynomial? And you got to be careful. Watch out for these negative exponents. Classifying, all kinds of good stuff today. You could basically consider this to be your test review. Yay, because we're almost there. And this isn't going to be a test for this chapter. This will be a quiz because it isn't a whole lot of material, but it's just stuff that we really kind of like, need to know. So enjoy, guys. Take a look at your notes. Make sure you've got a cheat sheet written down. I would say a little index card would be great. Put the important information on it. And that would be it for today. Have a good one, guys.